Well, welcome to today's discussion. Um, we're excited to have Judy Fitzpatrick joining us today. Um, I am Trevor Greenfield with RioMax, and I'm the founder and co-owner of the company. We're just excited. I don't really know if there's another word. Passionate. Um, in terms of this journey that we're on, and that is looking at agriculture as a complete system. So we've got to take into account, the livestock, the microbes in the rumen of the cow, for example, the how that impacts the soil health, all the way through to plant health and back up to the livestock. And of course, there's the human element in there too. So we're on a wonderful journey. Judy, I'd be glad if you'd introduce yourself.
Okay. Hi, I'm Judy Fitzpatrick. I was in medical diagnostics. I had a company and I developed quite a few medical diagnostic tests, and then took early retirement and started teaching. And while I was teaching, they asked me to get a National Science Foundation grant. And while I was on this grant, we started working on a quality control test for soil, which was, I was introduced to this area by one of my co-founders who unfortunately has died at the age of 52.
Oh,
He sustainably maintained all of New York City and worked on many, many projects throughout the United States, um, doing things the natural way. And when I first went to his talk, he said, the one thing we really need is a test for microbial biomass, because if the microbial biomass is healthy, then the plants are healthy and the soil is healthy. And we don't need pesticides and we won't get soil erosion. And right now, the only test you really can rely on is $500. So I started working on it with students, and it has changed quite a lot since then. But we now we call it microbiometer because in the beginning it actually there was a kind of meter associated with it, but now it's read by cell phone. So what we do is we extract the microbes from the soil using an extraction fluid and whisking for 30 seconds. And then we let it settle for 10 to 20 minutes. And the newest method is 10 minutes with a filter. We can cut the time. And then you put 3 drops on a test card and take a picture. And from the picture, comparing to a graded eyeball like we have around where you put the drops, we can calculate the micrograms of microbial carbon per gram of soil. And we correlate with the $500 test 95%. So basically, we are providing the same information as the $500 laboratory test. The issue is that since these tests were so expensive, people have never really had guidance for how to actually use the test. And the need for such a test has only really become important as people move more into sustainable and realize that the chemical tests they've used before are not really able to give them all the information they need in order to make wise decisions in terms of going sustainable or going organic.
right. Well, I would like to put a plug in for your equipment. We invested in a microbiometer last year, or in the test kit. And what I love about it is it puts the ability in your hands to get real-time tests. And like what you say, people off by what scares people off from actually digging in and taking measurements so they know where they're at is that big price tag. But when you've got a tool that can give you real-time readings, I think that is great. And we certainly, as a company, we certainly enjoy that. Now, let's talk about this. Judy, why is it important to measure microbial biomass? What is microbial biomass an indicator of?
Okay, so microbial biomass depends on the same balance of all the nutrients in the soil, but that a plant needs from the soil, except carbon. Okay, so, but it does require carbon. Okay, so you have to have the correct balance of carbon, nitrogen, potassium, sulfate, etc. All of the minor minerals that people talk about. If you have lots of carbon, but you don't have a sufficient amount of the other minerals there, you're not going to have a healthy microbial biomass, because the function of the microbial biomass in terms of plant health is to transfer to the plant the nutrients from the soil. So it basically, its function is to mine the soil for those nutrients. And a chemical test does not give you the end all of what's available to the plant. For example, you and I have discussed the fact that there's a lot of phosphate. People figure more phosphate than most soils need for almost 100 years, but it's not bioavailable. And it doesn't show up necessarily in your chemical tests. But your fungi especially, and bacteria also can help, and make that phosphate that's associated with rock materials, make it available to the plant. Yes. And microbes also have the ability to make nitrogen available. Even there are free living rhizobia that can fix nitrogen from the atmosphere and make that available to the plant. But none of those microbes are turned on if you're using heavy doses of mineral fertilizers, because the stimulation for the plant to feed the microbes is that it needs nitrogen, it needs phosphate, it needs these. So when it needs these things, it puts out foods that are specific for the type of microbe that's going to provide them for it. So it makes sure that it's enriching the area in and around the root for the types of microbes that it needs. And if you're using heavy phosphate, you're not getting the fungal colonization that you need. The fungal colonization of a plant can increase the plant root area by 1,000-fold.
Wow.
Okay, that allows it to get into small areas that the root actually, because it's so much smaller, the hyphae are, that they don't do it. And it gives the plant access to 1,000 times more moisture and other nutrients that are in the soil. So we can't, if you have a healthy microbial population, including fungi, your soil needs 50% less rainfall in order to maintain health.
That's amazing, and it gives us so much hope, Judy. In industrialized agriculture, we've almost become our own victims to our own practices, because the soil is addicted to those synthetic fertilizers, because without them we can't get the plant growth and plant yield, because we're trying to prop up a broken system. We're trying to prop up a system that is flawed. Now, what you're describing to us in working with Mother Nature is that you're doing things that can cascade into a much bigger beneficial impact with those excuse me, what was the word you said? Was it the mycorrhizal fungi?
Mycorrhizal fungi, yeah.
So that is just very, very enlightening, and I say we as an industry are addicted to these inputs, synthetic fertilizers, whatever they are. So as we build the soil health, Judy, are you saying that we're going to enable ourselves to be able to wean ourselves off of these expensive fertilizers?
Yes, and I like your analogy of addiction. Because if a person's addicted, you know, there's a process by which you become unaddicted. Okay.
Right.
So obviously, you know, you take a soil that you have basically robbed of its of its microbial biomass, because we see if you're for fields that are, you know, primarily mineral fertilized, we never see microbial biomass above 100 micrograms per gram of soil. So, you know, it's always 3 to 10, 20 times less than you should see in a healthy soil. Okay. And it's not well balanced when it's like that, okay? Because these chemicals are toxic for some of the microbes. So, you know, you're going to have to experiment based on your soil and based on the amendments you're using, okay, and when and how you apply them and at what concentration. And you may actually have to wean your soil away in order, you know, more slowly than one would like, actually, in order to maintain yield as you're transitioning.
Yes. And I think that's a good point you make, because we get asked that question a lot. Okay, so if I use rhizogreen, which is our microbial stimulant for the soil microbes, if I use that, can I quit using fertilizer? And we say the answer is yes, but it's a process. So no, not cold turkey. Like you said, we got to wean ourselves off of these things that we become addicted to. And in doing so, we set in motion a natural response that is absolutely wonderful, because suddenly you start working with Mother Nature, and we're talking about this nutrient cycle. And a benefit of that, Judy, would be the carbon sequestration, which is talked about more and more these days. Can you speak to that point?
Okay, so the United States has lost more than 50% of the carbon that was stored in its soil. And the soil holds maybe 3-4 times the amount of carbon that the atmosphere does. The atmosphere holds it as carbon dioxide, but the soil doesn't store it necessarily as carbon dioxide. The plant takes carbon dioxide and turns it into protein and amino acids and carbohydrates, etc. And those can be stored. Generally, those are stored in microbes, okay, as they die. So most of the stored carbon in soil, 60 to 80%, is basically the remains of dead microbes.
Right.
And this is a big process because microbes are dying all the time. Okay, so a microbe can reproduce, you know, every 15 minutes under some conditions.
Is that right?
But they also die. So the process is, a lot of times when they die, the materials that leak out of them are used by adjacent bacteria and used immediately. But over time, if you have excess if you have enough microbes, some of that material becomes deposited in the soil. And it's kind of a gradual process, okay, where it becomes associated with clay and with the minerals in the soil. So your ability to store carbon in your soil is going to be regulated by the type of soil you have, by the mineral composition, as well as the clay composition. And when it's then stored stably, it's very hard for the microbes to get to. They have to work very hard to release that because it's stuck. It's chemically bound actually to some of the clay materials and minerals. So they have to separate it. Okay, they can readily use the broken down organic materials that are available from last year's crop and maybe the year before, and from microbes that have recently died, and they need that. And basically you need to provide that. So you need to provide that, from last year's crop, from a good, very good source of carbon that's then very available to microbes is roots. This is one of the big advantages of cover crops, is the cover crop has good roots, the roots remain in the soil, and that's a big carbon source for the microbes that are going to live there. But you do want to make sure that the microbes that you're encouraging with your cover crop are the microbes that are going to best assist your field crop.
Right, right.
So there is a match that you want to do there, that you do it.
Okay. And I think that's an important point you make, because the question we get with our Rhizogreen is, oh, is this bug in the jug approach? Is this adding microbes to the soil? And just to clear the record, no, it is not a bug in the jug. It's not microbes that we're adding to the soil. Rhizogreen is also not a plant food, right? It's not like a micronutrients that folks use for plant growth. What Rhizogreen is a direct food source, like a superfood, for the microbial population within the soil. We're not feeding the plant per se, we're feeding the thing that feeds the plant. And so stimulating and hyperactivating those beneficial microbial populations in the soil is what you talked about, serving to unlock the nutrients that are there. Now, for the people that are considering, these different options, whether it's a direct, adding microbes to the soil, or using a product like ours, Rhizogreen, where we're feeding the bugs. We're going further upstream, right? We're feeding the bugs that will then break down that nutrients in the soil, and the plant will uptake it. So what's your opinion on feeding those microbes to the soil, bug in a jug?
Well, of course, what everybody recommends, and we do too, is feeding your microbes.
Okay.
And more, we've come to the conclusion that basically the best thing to do is to encourage the microbial population that is endogenous to your soil and to your crops. And we do see that as we increase the microbial population, we record an increase in diversity. I'm not sure that that's an actual increase in diversity. I think it may be that as you increase the amount of microbes from like 100 to 600, then something that was only 1% now becomes visible.
Yes.
So I think a lot of these microbes are probably in the soil, but in very low quantity, and haven't really been encouraged. And what I love about them is they're such a community. Okay, so it's not like you want to just encourage one type of bacteria, because bacteria have a very small chromosome. So bacteria are very limited in what they can eat. Okay. And their digestion occurs outside of the bacterial cell.
Oh.
Okay, so they put out the enzymes, and the enzymes break down foods. Okay, and so some of what is broken down is taken up by this bacteria itself, and some can be scavenged by another bacteria.
Oh, really?
Maybe there's some part of it. Oh, yes. So they share food, they share enzymes, they share vitamins.
So they are truly a community.
They are a real community. and they have to be a thriving community in order to be able to provide everything. They're providing things to one another. So it's not like any one of them can like live on their own.
Yeah.
And we're only just beginning to really understand how complex this community is. I mean, the brassicas don't usually get AMF, arbuscular mycorrhizal fungi. But just recently, someone published that providing it, even though they didn't provide, as I could see, evidence of colonization, it still increased the health of the microbial community and of the plant.
Yes.
Because we're talking about a community that takes care of itself. And people have done studies showing, like, if you put vitamin B in or you put vitamin D in, some bacteria that couldn't grow without it grows. And if you take your soil and you plate it out on a plate and you grow it up over time, different microbial populations keep showing up because one lives off what another doesn't live on.
Wow.
And we've known this for a long, long time. Okay. And these guys are very resilient. I mean, I often like to say, they've been around for 4 billion years. Most species don't last that long.
Yes.
They share food, they share DNA. To be a species of bacteria, you can have a 20% difference in DNA.
Wow.
That's the difference between us and a cow. There's 1%, less than 1% difference between us and our nearest primate, a gorilla.
Right. Right.
So, they're it's a very resilient population, and it can, given the right resources, it can take care of itself, and it will take care of the plants that are there, because the one thing the microbes don't have is carbon.
It trades that with the plant, right?
They trade. So there's a very active trading process going on all the time. Actually, there's been wonderful research shown about how the AMF, the arbuscular mycorrhizal fungi, that attach themselves and insert themselves into the root, not into cells, and they supply the phosphorus. They trade phosphorus for carbon with the plant. And, if the more phosphorus the plant needs, the more carbon the fungi extracts from that particular plant.
Wow. And
and they can show it. In the forest, actually, the arbuscular mycorrhizal fungi go from tree to tree. So it's a large conglomerate. It's not just one plant that's part of this community.
Yes.
And they will actually trade from one tree to another, and the tree that gives the most will get the most phosphorus.
Just it's like economics,
They have done economic studies saying it is very, very like economics. Yes.
That's wonderful. So what I'm hearing you say is that there's this trading that's going on, and the more we fix what's under the surface, it sets in motion this sequence of events, this natural cycle, because everybody's very conscious, or more and more so, conscious of the carbon, and the carbon sequestration and that whole discussion. But some of this fundamental microbial communities is at really at the heart of that whole discussion about sequestration, would you say?
Yes. If you don't increase your microbes, you can't possibly increase your sequestered carbon.
Right.
And the sequestered carbon a lot of it is a protein made by mycorrhizal fungi called glomalin.
Oh.
So the outside of a hyphae of a fungi is covered with a kind of almost mucusy. It's not really mucus, but it's kind of a sheath of glomalin. And that allows it to stick to the soil. Because if it didn't stick to the soil, it would wash away, like your chemicals. But all the microbes make materials that allow them to stick to the soil so they don't wash away.
And there you have
that material remains after they die.
Yes.
And that material causes soil to stick together and have texture. And it's that texture and everything that allows the soil then to make room for bacteria. They need oxygen, they need water. So it increases the oxygen and the water composition. It increases little spaces inside the soil where microbes can go and multiply and be away from, large predators and everything. And we're emphasizing, you and I, to a large degree, the bacteria, even though bacteria are not, not the only microbe or the only animal that's important to the soil. Okay, but they are the basis of the food chain in the soil. Yes. So they feed everything that feeds everything above it, that feeds above it, that feeds above it, that feeds above it. Okay.
Exactly. So, with those of us in farming and ranching, it's hard for us to get excited about things we can't see with the naked eye. So the approach that I take is, okay, you can use one of the your gadgets that can help you read the microbial biomass, because what you cannot manage what you cannot measure, and this is a great measurement tool. But the simplest way is to take a shovel and go and dig in your soil. And to me, okay, we can't see microbes, we can't see those microscopic organisms, but what we can see is earthworms. And so going back to last spring, we applied the rhizogreen on alfalfa, and we had a control and then the treatment. And then 6 months after application, using your tool, we measured the microbial biomass. And so this is not something we can see, but the tool helps us to be able to see it. And it was 131% increase in microbial biomass from the treatment to the control, only 30 feet apart. So you might say, well, that could have been, maybe that's not scientific data, whatever you want to say. To me, it proved a point. So that was last fall, we took that reading. Now, we're in March 2021, and the frost has gone out of the ground in Minnesota. That's nice and early. And so I couldn't wait to get back out and start looking at that soil again. So I did, and I took a shovel out there, and I dug about a square foot of soil out of the treatment area and a square foot of soil out of the control. And then I counted the earthworms. Like, hey, even I can do that. And there was 60% more earthworms in the treated area where we stimulated biology than the control. Now, does that align with everything we're talking about, Judy?
It does, because the earthworms are living on microbes. That's their food. And you're aerating the soil when you're getting that many more earthworms in there.
Oh, yeah.
You're creating a lot, you're relieving a lot of the compaction in the soil.
Right.
So it's fantastic. And of course, the material that comes out of the earthworms, the castings and everything, is even better for you than what we can get from regular compost, because the degradation process releases a lot of nutrients and makes them more available to plants and to microbes.
So the more I'm learning, and I don't claim to be an expert on this as you are, Judy, but the more I'm learning, the more common sense it becomes, because this cycle feeds itself. And what you find with Mother Nature is there's no waste, because what is left over from one animal is consumed by the next, and everything feeds each other. And now you talk about even trees in the forest being a community and being hyperlinked together, you might say, with these channels of communication and channels of nutrients and water. This is amazing.
It is amazing, and I guess it's amazing that we have underestimated plants for so long, and the plant is a superorganism too, because without the microbes, you've robbed the plant of its immune system.
Its immune system.
Yes.
It's more on that. That's obviously, this resonates with me because we've been in the livestock business, supplying nutrients to cow-calf producers for 18 years. And we're all about a healthy immune system, in this case, in a cow or in a calf. And we have a saying here, when you have a strong immune system, that calf will fight off weather challenges or stress factors. It will fight it off from the inside out. And it's amazing what a strong immune system in a calf can do in terms of resilience and less treatments and less sickness and all of it. Now you're talking about the immune system of the plant. I would love to learn more.
Well, I mean, the plant, like the human, farmers have far fewer autoimmune diseases and have better immune systems than non-farmers. And we know that's because they and their children are exposed to more microbes. So what happens is exposure to microbes actually improves your immune system. And it improves it by what we call priming it. So plants that are exposed to microbes just naturally can keep the pathogenic microbes in check. They can take care of them, because pathogenic microbes are around all the time, and they actually don't become pathogenic unless the host is stressed. Okay, so the person who has a healthy immune system makes a lot of antioxidants and different compounds that help them fight off diseases that might come along. And the same is true for a plant. So the plant and the big advantage to this, okay, and you have noticed it, okay, and I'll tell you how, is whenever people check organic food from non-organic food, what they report is the taste is much better. Okay, and the taste comes from the antioxidant materials, 20,000 of them, that are made when the plant is interacting naturally with a soil microbiome. And we say interacting, the plant and the soil microbiome interact very. There are microbes throughout the plant, just as there are microbes throughout us. Not only are there microbes circulating in the fluids of the plant, living inside the roots of the plant, living on tops of the leaves of the plant, okay? And the microbes are sharing metabolites with the plant. So a lot of the flavor that we associate comes from the fact that you're eating a healthy plant. And a huge study done in Europe a while ago showed organic farmers needed 97% less pesticides. Now, these farmers who are organic are allowed to use organic pesticides, but still they use 97% less pesticides.
Well, this is
And the taste is better. So you told me a while ago, why don't you tell a story about how your cows didn't want to move off?
yes. Well, this comes full circle because you're talking flavor, and who of us don't enjoy, that good fresh, pungent taste of homegrown vegetables, or grass-fed beef, or it's there's something about it, and it's coming full circle now to me, Judy, that this is all linked together. The other good point is that if we can reduce our dependence on pesticides, fertilizer, all of that, it's twofold. One, we're saving money, which everybody's interested in doing that. But more importantly, we're allowing nature to function as it was created, as it was designed. Now, back to these cows you're talking about, Mississippi, we did a trial there. So with the Rhizogreen, we did trials here in Minnesota, where our headquarters are, and then in Oregon and Idaho, high desert, and then in Mississippi, so the lush southeast. So three very different parts of the country in terms of soil type and forages and moisture. But this trial that was done in Mississippi, first of all, in terms of yield, which is the first thing everybody wants to talk about, the hay yield on the treated, Rhizogreen treated, was 10.21% increase compared to the control. So we had 10.21% more hay, off of that same ground. So that's cool, but that's not the best thing. When the rancher turned out a group of cows onto this hay meadow in the fall, so after he had taken the hay off, we just got a little bit of regrowth, about 5 inches. And he said there was enough for about a week, week and a half. And then the cows would have started to act hungry, walk the fences, start bellowing, all the normal things. He's done it for years. So because of that, he left the gate open so that they could back graze at any time. As soon as they started to feel hungry, or they weren't being maintained by that hay meadow, they could go back to where they come from and get their forage there. He said, "We got crazy things happening here in Mississippi." I said, "Well, what's that?" And he says, "Well, these cows are refusing to back graze." And he says, I didn't think there's very much forage out there for them. And he says, on top of all of that, he says, that group of cows is a half a body score ahead of all my other cows. So these, several hundred cows, all being treated the same, with the same supplement program, happens to be Riomax, but they're all getting the same treatment, except for this one group of cows on this treated meadow are saying, we don't want to leave, for one, and for two, we've gained a half a body score over all our contemporaries just because we're eating more nutrient dense forage. And the forage is more nutrient dense because we impacted the microbial populations in the ground. That came full circle. That was an aha moment for me.
Yeah. I mean, I think one of the things I also like to point out too is the USDA says there's no difference in the nutrient value, but they're just looking at protein and carbohydrate and a few things. Okay, the 20,000 nutrients that are made when a plant grows naturally and is naturally exposed to microbes, those 20,000 have anti-cancer activity. They have all kinds of activity, and they're not considered at this point nutrients by the USDA. So I think we can't underestimate, what we've cost ourselves by this heavy, actually very recent dependence on mineral fertilizers and how devastating it's been throughout the world, especially, more so in third world countries than in the United States, because as you point out, mineral fertilizers are an addiction. And I believe it went up like 8%. Usage went up 8% last year, because you continually have to use more and more, because there's less and less, microbes left in the soil able to provide anything to the plants.
Yeah.
So for millions of years, meadows have just kept going and kept building carbon in the soil, and now we've just been releasing it.
So you've mentioned in prior conversations as to you can feed the right amount of fertilizer, but overusage, which we typically do, has a negative impact on those microbes.
Yeah, there are studies showing that, like you could be using a green manure that, for some reason or other was low in one of the minerals that you needed, or nitrogen, and, judiciously supplementing with that and making sure that you're not putting down so much that you actually inhibit the microbes. So if you put down too much, you'll see a drop in your microbial biomass. If you actually just are supplementing the carbon source with enough nitrogen to balance it out, you should actually see an increase in your microbial biomass.
Good.
Okay. So, a small amount, and it depends on like what sort of nitrogen supplement you're using and the source of it. And, alternatively, there can be too much nitrogen. And, I guess some of the fertilizers, even the natural fertilizers that people use are, need to be mixed with something else in order to be balanced. And I think a big future is coming up with how to kind of balance the type of nutrition we're providing to the soil based on the soil. And, getting to the point where we can use the microbial population, since it's going to reflect the health of the plant, is reflected in the microbial population, and it's reflected much earlier than the plant. The plant takes till September or until harvest, whereas usually you get a message from the microbial biomass within weeks or even a week.
Is that right?
Yeah. So it's not to say that a lot of supplements aren't any good. The question is that supplement or is that treatment good for your soil and your crop and your climate and at this time?
Yes.
So, you can see that in a couple of days, actually.
So it comes back to one of the 6 basic principles of soil health, and that is context. Get your context right. And you kind of alluded to that. Now, if you mentioned, if we've got these fertilizers that have not been available to the plant over the last 100 years, and they're in the soil, if we work with those microbes and stimulate them, are we going to be able to mine or utilize those tied up fertilizers like nitrogen?
Yeah, we'll be able to do it. I mean, that's, if there's, the reason we've lost the organic nitrogen in the soil is that when there's not enough balance, like not enough nitrogen in the soil or phosphorus or something, the microbes will work very hard, make a lot of carbon dioxide, and they will mine that, stably stored carbon out of the soil. And they have done that, and they've done that all over the world. And as they've done that, we've really increased, we've decreased soil's texture. We've increased erosion. So the earth now has lost 50% of its soil. we've decreased our ability to hold water in soil. Okay, we've increased the amount of pesticides we're doing. So we've decreased the quality of our water, and we've decreased the nutrient value of our food. You know, we're at a point now where we're going to have to make changes. I mean, we have to.
Well, I think your message is giving us a lot of hope, because we know what changes need to be made. We know what industrial ag is addicted to. We know the negative unintended consequences, and I think that's where something like this, we need to keep working to educate people and raise that level of awareness, so people understand that when you kill off the bacteria in the soil, or you have a negative impact on the mycorrhizae fungi, and you do all of these things that are unintended consequences, you're actually eroding the very foundation of the whole system. So we know that, and I think we need to keep educating folks on that. And the beauty is that it's economically viable. It's not like something that is going to cost you. It's not like it's going to be cost prohibitive, because when you're saving on all these input costs, and you got Mother Nature is clicking, then you're able to still get your performance and the taste of the food. I like that part.
Yeah, I mean, what we hope is that we've provided a tool that can tell you within weeks whether or not the fix you're using, the amendment you're using for your soil, or the treatment, okay, is actually working to do what you want. Because, not all fixes are going to work for you. So, people need, a tool, like you said. If you can't measure it, you don't really know what's happening.
Yeah.
And nobody can walk into a farm. I mean, I talk to agronomists, what am I going to tell people? Well, I guess it's like dressing a woman. You can't say one dress is going to make everybody look good. We're all built differently, et cetera, et cetera. We all have different needs. So, and so does your crop matters, what you're doing, and hopefully we can all go, we can work it out without, suffering damage, because people have jumped too quickly to solutions that didn't work. Yes. And I have people contact me and say, this field is organic and this field isn't. Why is the microbial biomass the same? Well, just going organic doesn't necessarily provide everything that you need to your soils.
Right.
You need fertilizers that are actually going to provide what that soil is missing. And you can use organic fertilizers, but you probably have to balance them and work with them. And maybe for a while, you'll have to do some supplementation or something.
Yes. So it's that process of weaning yourself off of it. And I think it's very clear that it's not cold turkey. In fact, I personally know a producer that made changes too fast because they were so passionate about it. And they had a wreck, and they will talk about it openly because they don't want other people to go down that same path. However, if we can show people there is a success path, there is a plan for you to pull out of this, depend less on these synthetic fertilizers, and get your soil dialed in to the point where we start this whole system working again, and we start to experience the synergy of Mother Nature, and we have to just stand in awe of that.
And I definitely endorse, the concept of feeding the microbes, not trying to change the population of the microbes, because you add microbes to soil, you're putting a stranger into an area that's been dominated by billions of microbes for ages. And I think I told you that when I look at most of the ones that are sprayed on, it's like dropping 2 Americans into China and saying they're going to multiply and take over. No, the reason these microbes make antibiotics and other substances is to protect themselves from other microbes. So like any group in the United States, they protect their, there's little protective zones. They, you can grow this much, but once you grow this big, our alarms go off and we're going to do something about it. Okay. So that's what the microbes do. And they're not basically going to welcome strangers. Okay. So I think the way things are moving now is grow the microbes, a healthy population that is based on the population in your soil.
That's excellent. So you're working with that native, naturally occurring population. And, to back your comment up, when we first started talking to some of our customers about this concept of feeding the microbes, I had a customer in Montana say to me, "We're not interested. Don't bring it to Montana. We've tried liquid fertilizers before like this, and we're not interested." And I said, "Okay, that's fair enough, but tell me, what were you using?" "Well, we're using the bug in a jug approach, and it doesn't work. It might work in Illinois, it might work in Iowa, it does not work in Montana." So I was like, wow, okay, that's good learnings. I appreciate that. I said, "Well, just to clarify, this is not a bug. This is the food source. This is like a cocktail, a multi-component cocktail that is a direct food source for the soil microbes." "Oh," she says, "okay, well then in that case, I'm very interested," because she had seen the other thing fail, just trying to throw those Americans into China and hope they'd overcome the country. She experienced that, and she was very leery of that. And I said, "No, this is not what we're doing." And there again, education. We need to educate people so they understand the mode of action is so simple. It's feeding biology in the soil, and which then sets in motion a response that is amazing. And like I said, we have to stand in awe of what nature does.
Yeah.
Well, thank you, Judy. I appreciate your time you've spent with us today. And I've found it extremely insightful, educational, but more than that, it's exciting. And I think you're really breathing hope into the industry, that some of these fundamentals are right beneath our feet. So thank you for joining us today. And thank you to all the listeners. I hope this has helped you see that the success path ahead is simpler and more achievable than we ever thought. Judy, what's your thoughts?
Well, I think, you're on the right track. We have to build our microbes, and we have to do that. And I'm just really enjoying the fact that we're at a good time in history now where people are embracing this kind of thinking and action. And I'm really happy to be a part of it and to be working with people like yourself, Trevor.
Well,
thank you very much for hosting me.
Thank you very much.
Thank you.